Hi friends, in this video we are going to discuss about synchronous motor. Up to now we discussed about alternators. Now synchronous motor. Synchronous motor nothing but an rotating AC electrical machine. What is it? It is a rotating AC electrical machine which converts electrical energy into mechanical energy. What it converts? It converts the electrical energy into mechanical energy by utilizing DC excitation. This is very important. Here we are utilizing the DC excitation. Nothing but, see here, is it okay? Right? For example, this is my synchronous motor. Here the input of the motor is electrical, nothing but voltage and current, and the output of my motor is mechanical, nothing but speed and torque, and this is excited by DC supply. Here we have an armature. The armature produces AC supply. We are giving DC supply to the, here we are giving AC supply to the armature, what happened? AC supply given to the armature and DC supply given to the field winding. What happened here? Generally we have an armature on stator and field winding on rotor. This armature on stator given by three-phase AC supply, field winding on rotor given by DC supply. Hence, synchronous motor is a double excited machine. This is exactly a double excited machine. Are you okay getting or not? In generally, 90% of synchronous motors are salient pole type only. Salient pole type are nothing but low speed applications only. This is in generally used for low speed applications. So they will ask you a question, what are the applications of synchronous motor? If they ask you a question like that. Generally synchronous motors are used for low speed, high power, constant speed applications. These are the general things of my synchronous motor. What is that? Low speed. Sir, low speed nothing but 300 to 600 RPM range. High power nothing but 500 to 2500 kilowatts range. Constant speed nothing but the rotor speed is equals to synchronous speed. So what are the applications of synchronous motor? Low power, low speed, high power, constant speed applications. Can you give me examples of these applications? Can you give me? Yeah, exactly. Textile mills, still paper mills, textile mills, and also used in induced and forced draught fans, induced and forced draught fans. Still, these are also used as a wind blowers. Still, these are also used as a synchronous condenser. This is very most important applications of synchronous motor. These synchronous motors are used as a synchronous condenser to improve the power factor. Why we are using synchronous condenser? To improve the power factor, we are using synchronous condensers. So generally, these are the applications of my synchronous motor. What is synchronous motor? And 90% of synchronous motors are salient pole type, nothing but low speed applications we are using. And here the main disadvantage of this synchronous motor is that, can you tell me what is the main disadvantage of my synchronous motor? Yeah, very good. Starting torque of my motor is exactly 0. Nothing but synchronous motor is not a self-starting motor. Not a self-starting boleto. The starting torque is equals to 0. There is no starting torque. Even though we are using these synchronous motors instead of induction motors only in some cases where constant speed is there and high power is there. For high power and constant speed applications, for these applications, synchronous motors are more preferable than induction motor because cost is less for these applications. Synchronous motor cost is less for these applications. That's why even though the starting torque is 0, we are using this synchronous motors in industry for constant speed high power applications compared to induction motors. Right. Simply, this is about the synchronous motor overview. Are you okay? Now, the next topic, simple loop analysis. Okay? Right. Thank you.